What's up, students? It's Hutch here, and you're on Module 7-5. This is a lesson on determining the number of solutions, something really new for you in the sense that most of the time you run into things just having one answer, one solution. And today's all about understanding that that's not always true. Sometimes with algebra, you have no solution, one solution, or an infinite amount of solutions. And we want you to be able to determine how to create those equations and also recognize those types of equations. Okay, and so a couple things I want you to see is we have these couple different scenarios here. So when an equation ends up being a number equals a different number, obviously that doesn't work. A 4 doesn't equal a 0. So that's called having no solution. So don't think that you did something wrong. That actually is the way something could play out, and it could have no solution. One solution is when you run into the very common thing that you're used to, a variable equals a number. Okay. The last one is when a number equals a number. That is a true statement. A 2 equals a 2. But when you lose your x's, meaning if I subtracted 4x to both sides, my x's go away completely. When you have this scenario, that's what creates an infinite amount of solutions. Because think about it, I could put a 2 in for x, and 4 times 2 plus 2 on both sides is going to create the same thing. Just like if I put a 4 in for x, 16 plus 2 and 16 plus 2 is going to make the same thing. And so it's always going to work out like that. So we want you to be familiar with those kinds of solutions to be aware of that. All right, so let's go ahead and try it out and see what happens here. So your first step in solving an equation, is to simplify it by getting rid of parentheses, combining like terms, all that kind of stuff, and then working backwards order of operations. So we're going to go ahead and distribute to get rid of the parentheses, and then we'll go ahead and put our answer down below just to save time from rewriting. So we have a 6x, and then 6 times negative 3 is negative 18, plus 10 equals 6x minus 8. I'm just doing the distributing there. Let's go ahead and separate our workspace. Okay. Now we know that the next step, this is nothing different than we've done, is to combine like terms. Okay. There's no combining like terms on the right side. All right. Let's go ahead and do our rewrite. So we have 6x. And then different sign, subtract, keep the sign of the bigger number, then you'll be exact. Minus 8 equals 6x minus 8. And you can see these are exactly the same expression on both sides of the equation. So obviously, just like this, it's going to end up creating an infinite amount of solutions, because I would go ahead and minus 6x to both sides. And I am then left with negative 8 equals negative 8. Okay, and so this would be called infinite solutions. Okay, and so I want you to go ahead and write that, and you're done. Okay, and so it says check the solution, replace x with any value to verify that any solution would work. Okay, so you can go back up, and if we did this, 6 times the quantity of, let's just do, we'll keep it simple. We'll do 3. We'll make x equal 3 instead and see what happens. Equals 2 times the quantity of 3 times 3 minus 4. Okay, so we're plugging this in, see what happens. So what we end up with, 0 times 6 is 0 plus 10. We end up with 10 on that side. Multiply first. 3 times 3 is 9. 9 minus 4, 9, 8, 7, 6, 5. 5 times 2 is 10. Okay, so you can see you can plug in anything you want. Okay, and it works. Let's go ahead and try it on here. They're asking us which equation has an infinite number. Okay, so we're looking for that format. Infinite means we end up with a number equals a number, okay? Or simplified, both sides have the same expression. Let's go ahead and separate your workspace here. We need to simplify these to see the simplified expressions. To do that, we know that we distribute to get rid of the parentheses, then we'll combine any like terms. So we have 6c, 2 times 6 is negative 12 minus 2c equals 4c plus 16. Let's go ahead and combine our like terms. We have our 6c and our negative 2c. So different signs subtract, 6, 5, 4, and we end up with 4c minus 12 equals 4c plus 16. Now, the coefficients are the same, but the constants are not. Okay, so this is not going to leave us with the same number. If I subtract 4c on both sides, we can see that we're just left with negative 12 equals positive 16. And so when we have a number equaling a different number, remember if we look back up here, a number equaling a different number means no solution. Okay, so this one is not the answer. Let's go ahead and write what this is, though. This one is no solution, okay, which means we hope that this one is the infinite. So let's test it out to be sure. So we're going to distribute so that we can simplify and combine like terms. And we have an 8x minus 9, and we're going to hope that this side creates 8x minus 9. So 2 times 6 is 12x minus, and then 6 times 12, oops, not 8x minus 9, silly. Common mistake, remember you don't want to mess that up, 72. 6 times 12 is also 72. And then we have our minus 4x. Okay, let's go ahead and combine like terms, and look what we end up with. We end up with an 8x minus 72 equals 8x minus 72. So we know if we continued, we would end up with negative 72 equals negative 72. Let's go ahead and get rid of our 8x's here, and we can see, there we go. And when we have a number equaling the same number, that means that this equation has an infinite solutions. We could put any number in for x, and it's always going to work. Okay. All right. So B is our answer. Let's go ahead and shade that in, and there we go. Okay. All right, let's go ahead and look at example 2. It says equations with no solution. So we know that we're creating things like this, where we have a number equaling a different number. Let's go ahead and test it out and try and see how that works. So we need to simplify both sides by getting rid of parentheses, then combining like terms. Let's see what we get. We'll do our rewrite here. So 38. Oops, 4 times 8 is 32. Careful there. And then 2 times 8 is a negative 16x equals 12. And then 5, 10, 15, 20 minus 20x. And then we also have a plus 4x we don't want to leave behind there. Let's go ahead and separate our workspace and go ahead and combine like terms on that right side. So we have a negative 20x and a positive 4x. Let's rewrite what we get here. 32 minus 16x equals 12 minus 20, 19, 18, 17, 16x. Okay, so we can see that we have the same coefficient, the negative 16. Remember, coefficients are the co-pilots to the x. So if we add 16x to both sides, it completely goes away, and we end up with 32 equals 12. When we have a number equaling a different number, that means no solution. Okay, no matter what we put in for x, it's not going to work. Okay, all right. Let's go ahead and find the equation with no solution. So let's check A first, separate our workspace. Remember, step 1 is to simplify the expressions on both sides so that we can see what they look like. So we have 5b plus 15 minus 2b. Careful, make sure your b's don't look like 6s. And then we have a 2b plus 3. Let's go ahead and combine like terms. We have our 5b and our negative 2b. 5, 4, 3, and so we have 3b plus 15 equals 2b plus 3, okay? All right, so this one, if we continue to play it out, we have minus 2b minus 2b. Okay, this seems like a normal problem that we'd do. So we have b plus 15 equals 3, and then we would subtract 15 from both sides. So that goes away, and we end up with b equals 15, 14, 13, 12, negative 12. So if we actually have a b equals something, this means that we have one solution. Okay, so that's not our answer, so it has to be b, but let's go ahead and make sure. Excuse me. All right, so we're distributing. So let's go ahead and write our next line. 10y plus 18 equals negative 15y. And then negative 3 times negative 7 is positive 21 plus 5y. Okay, we know that we combine like terms to simplify. And we're left with negative 10y plus 18 equals negative 10y plus 21. So we have the same coefficients, but different constants. So when I add 10y to both sides, that goes away, and I end up with one number equaling a different number. And we know that means no solution. Okay, and so there's our one with no solution, highlight it, and there we go. All right, now you're starting to realize that maybe you can recognize some of these patterns where you wouldn't really have to even solve it all. You can start to notice the expression patterns that will determine no solution, one solution, or infinite. So let's take a look at that. When we have no solution, okay, you can see, remember coefficients. I remember this by thinking like the co-pilot to x. Okay, so these are the coefficients, and these coefficients are the same, but the constants are not the same. They are different. Okay, and so that makes it where we end up with the coefficients going away because they're the same, and we end up with a number equaling a different number. Okay, when we have one solution, we can see that the coefficients in this, we have a 6x and a 4x, the coefficients are different. Okay, and the constants, they can be different or the same, okay? But no matter what, we're going to end up with an x equals something with those ones. And then to have an infinite amount of solutions, you can see the coefficients are the same and the constants are also the same. And that's what's going to make it where we have them equaling the same exact thing on both sides. And no matter what we put in x on either side, it is going to create one number equals the same exact number. Okay. All right. Let's go ahead and test this theory out and get comfortable with this. So what numbers would we have to put in here? Okay, so that the equation has an infinite amount of solutions. And infinite means that the expressions are the same on both sides. Okay, so that's what we're creating. So step one is still going to be simplify. Okay, and we know simplify means get rid of parentheses and combine like terms. So that's what we're doing here. You can see that we have our 6x and our negative x and our positive 2x. And when you combine those, 6 minus 1x is 5x plus 2x is 7x. Okay. And so you can see we have that here. So 7x plus 4, what does the right side have to be? Well, remember, it has to be exactly the same. So 7x plus 4. Okay. All right, let's go ahead and try that same thing over here. If they just said, hey, can you fill in these boxes with the values that will make us have an infinite amount of solutions? Well, because this isn't simplified, it's hard to know what should be in there. So the first step, as always, is going to be to simplify things. So let's go ahead and separate your workspace here. So we have a 4x minus 2x, and then we have to distribute the negative 2. It's the whole thing, don't forget. So negative 2 times 5 is minus 10. Okay, equals blank x minus blank still. Okay, let's go ahead and combine our like terms. We have our 4x and our negative 2x, and so we're left with 2x minus 10, and what has to be on the right side for it to be an infinite amount? For it to be an infinite, it has to be exactly the same thing on the right side, so that's nice and easy for us to do, right? So it's going to be 2x minus 10, okay? And then that is how that has to look, and we know it will work out because of that format. So let's go ahead and create some equations with no solution. And so remind yourself, no solution means that you're going to end up with, I'll go way up to the top here. No solution means a number equaling a different number, okay? And the way to do that is the coefficients are the same, but we have different constants, okay? So same coefficients, different constants. So let's go ahead and try this one out. Okay, and I don't expect you to remember all that. You can always refresh back. Okay, let's go ahead and separate our space. Okay, so we want to create same coefficients and different constants. Okay, so that's our goal. So let's go ahead and distribute here. To simplify this, we have a 6x plus 3 times 4 is 12, minus 1x equals blank x plus blank. And then let's go ahead and combine our like terms here. So we end up with what? 5x plus 12 equals, now we need same coefficient, so I need a 5x minus, and I can just make it be 10 or something like that, okay? And so what numbers would complete the equation? So it has no solution. This would be it, because I would do minus 5 to both sides, and I would end up with different numbers, okay? So there we go, okay? Let's go ahead and try that with this one as well. So if you want to pause and try it out yourself, you can. It's up to you. Okay, separate the space. Oh, we don't have to distribute. We can just combine like terms. Okay, so here we go. Let's go ahead and do that. So we have, let's see, this is a 1x. So we have an 8x, 7, 6, 5x minus another puts us at 4x minus 6. Okay, what do we need to have? Same coefficients, different constants. Okay, so we need to have the same coefficients, and I'll do minus 5 instead. And then when it gets rid of the 4s, I'm left with a number equaling a different number. Okay, so there you go. All right, that's it for your notes. Let's head to your practice and homework. It's just one page today to get this practiced. So it says solve each equation, determine whether the equation has one solution, no solution, or infinite. And you are going to want to bounce back to your notes frequently to take a look at that. Okay, so let's just do a couple together as a refresher of what you're doing here. So right away, I'm separating my workspace. I know step 1 is to simplify my the expressions on each side. And so we are left with a 4x minus 32 plus 12 equals 4x minus 18. I know I need to combine like terms, so that's the constants right there. And so we're left with 4x, different sign, subtract, 32 minus 12. So we have 32, 22, 21, 20. So we have minus 20 equals 4x minus 18. Now look, I have the same coefficients, different constants. I already know that this is going to be no solution, but it does say solve each equation. So we're going to go ahead and subtract 4x on both sides. And we can see we're left with negative 20 equals negative 18, and that is a no solution. Okay, because a number can't equal a different number. Okay, let's go ahead and do this annoying fraction one together. We know we need to distribute, and so let's go ahead and write what we have now. I'll stick with blue. We have a negative 4y minus 3 equals 1/3 times 12 is the same thing as 12 divided by 3. So 12 divided by 3, that would be 4y. And then 9 divided by 3 would be 3, 6, 9. We have 3. So minus 3. And then minus 8y. Okay. All right. So let's go ahead and continue. We need to combine like terms. So we have a 4y and a negative 8y. And of course, you could do that math work on your Desmos calculator as well. And so we're left with negative 4y minus 3 equals 87654, negative 4y minus 3. When we have the exact same expression on both sides, we know that we're going to end up with one number equaling the same number. And so we just have to remember what that means. Let me switch colors here. So plus 4y, and you're left with negative 3 equals negative 3. Okay, and what's that mean? Well, that means if you look back at your notes, okay, so I'd go back to your 7-5 notes here, maybe have it on the side. Okay, so when you have a negative 3 equals a negative 3, a number equals number, that means an infinite number of solutions. So infinite solutions. Okay, all right, so that's what you're doing with 2 and 4 that you can do on your own. Let's go ahead and practice completing each equation so that it has an infinite, and completing each equation so it has no solutions. Okay, so I'll do 5 with you. Okay, we know step 1, separate our workspace. Step 2 is to simplify the 1 expression. And so we have a 2x minus 7x. Don't forget to distribute the whole negative 7. Negative 7 times 10 is negative 70. Okay, if we combine like terms, we have a 2x and negative 7x. Different signs subtract. Keep the sign of the bigger number, 7, 6, 5. So we have a negative 5x minus 70. So what has to be on the right side so that has an infinite amount of solutions? Okay, well, infinite means, remember, we need to have the same exact expression on both sides. So we have to have negative 5x minus 70. Okay, all right, so there's that one. Let's go ahead and try number 7. This one has to be no solution. So no solution means that we end up with a number equals a whole different number. Okay, what's the format for that? Well, the coefficients are the same, but the constants are different. So let's go ahead and try to get that set up and create that. Okay, no distributing, we just have to combine like terms. So we have all those. So let's see, what do we have? 15 minus 4, 15, 14, 13, 12, 11. Keep the sign of the bigger, so we're at negative 11 and a negative 1x. So this is negative 11x, and we have a negative 1x, so we actually have a negative 12x plus 2. You gotta be really careful there. All right, what do we need to have? It says the same coefficients and different constants. So that way, when we would get rid of the coefficients, so we'll just do plus 3. Okay, so there we go, 12x plus 3. So you're going to do the same thing for 6 and 8. And then take a look at number 9. It says, which of the following explains why this, right here, has no solutions? So if you distribute this and distribute this, analyze that and figure out which letter explains why you already know that that would have no solutions. All right, there's your homework. Go ahead and work on that. And if you need any help, you can talk to me later.